Picture this. In massive floating sea cages scattered across Southeast Asian waters, over 15 million grouper are being raised in what has become a $3 billion industry that supplies the most exclusive restaurants from Hong Kong to Singapore. These prized predatory fish, some weighing up to 20 pounds each, represent one of the most challenging and profitable forms of marine aquaculture, commanding prices of up to $60 per kilogram in premium Asian markets. What makes grouper farming so incredibly complex that it requires 7 different water temperature zones and costs up to $50,000 per cage to establish? How do farmers successfully breed these fierce predators that naturally live solitary lives in coral reef environments? And what sophisticated industrial processes transform these exotic fish into the premium cuisine products served in Asia's most expensive dining establishments? Welcome to AgriCraft, where we dive deep into the world's most fascinating and profitable agricultural enterprises. Today, we're exploring the remarkable world of grouper farming, a cutting-edge form of marine aquaculture that combines traditional Asian knowledge with advanced agriculture technology. From the high-tech hatcheries where millions of microscopic grouper larvae begin their journey to the precision processing plants where mature fish are prepared for luxury cuisine markets across Asia, all will be revealed in this video. The story of grouper begins in the warm coral reef ecosystems of the Indo-Pacific, where over 100 species of these powerful predators have ruled tropical waters for millions of years. These remarkable fish are apex predators known for their ability to swallow prey nearly half their own size, using powerful suction to inhale everything from small fish to crustaceans in a single gulp. Traditional fishing communities throughout Southeast Asia have prized grouper for centuries, considering them symbols of prosperity and good fortune. In Chinese culture, serving whole steamed grouper at important celebrations represents wishes for abundance and success, making these fish essential elements of wedding banquets, business dinners, and festival celebrations throughout Asia. The cultural significance of grouper extends beyond simple nutrition. In traditional Chinese medicine, grouper meat is believed to strengthen the body and improve vitality, while the swim bladder is processed into expensive soup ingredients that can cost hundreds of dollars per bowl. This cultural reverence helped establish grouper as one of Asia's most valuable food fish long before modern aquaculture existed. Wild grouper populations supported substantial fishing industries throughout the region for generations, with experienced fishers knowing exactly where and when to find different species in complex coral reef environments. However, the combination of overfishing, habitat destruction, and growing demand from increasingly affluent Asian populations began putting severe pressure on natural stocks by the 1980s. The crisis deepened as traditional fishing grounds were depleted, and wild grouper became increasingly rare and expensive. Premium species like giant grouper and Napoleon wrasse commanded such high prices that fishing pressure intensified even as populations collapsed. This unsustainable cycle threatened both the fish populations and the livelihoods of communities that depended on grouper fishing. The transformation from wild capture to controlled cultivation began in the early 1990s when marine biologists in Taiwan and Singapore achieved the first successful breeding of grouper in captivity. This breakthrough required solving complex challenges including hormone-induced spawning, larval nutrition, and disease management that had previously made grouper farming impossible. Early pioneers faced enormous difficulties since grouper larvae are incredibly tiny and require live food sources that were difficult to produce consistently. The mortality rate in early hatcheries often exceeded 95%, making commercial production economically impossible. Years of research gradually improved survival rates and established the foundations for today's industry. The breakthrough came when researchers developed reliable techniques for producing the microscopic zooplankton that grouper larvae require during their first weeks of life. This achievement, combined with improved water quality management and disease prevention protocols, finally made commercial grouper farming viable in the late 1990s. Today, grouper farming represents one of Asia's most valuable aquaculture industries, with major production centers in China, Malaysia, Indonesia, Thailand, and Vietnam. China dominates global production, operating thousands of sea cages and land-based facilities that produce over 200,000 tons of grouper annually for domestic and export markets. The economic impact extends far beyond the farms themselves. The grouper industry supports specialized feed manufacturers, equipment suppliers, processing plants, transportation networks, and thousands of restaurants that depend on consistent supplies of high-quality fish. This value chain generates hundreds of thousands of jobs across the region. Modern grouper farming has also become a technology-intensive industry that attracts significant investment and research. Advanced monitoring systems, automated feeding equipment, and sophisticated genetic selection programs represent millions of dollars in agricultural technology designed to optimize production efficiency and fish quality. The complexity of grouper farming begins with selecting appropriate species for specific market demands and environmental conditions. Over 20 species are now farmed commercially, each with distinct characteristics, growth rates, and market values that determine their suitability for different operations. Giant grouper, the largest species, can exceed 400 pounds in weight, but require enormous cages and extended growing periods of 3 to 5 years before reaching market size. These giants command premium prices but represent substantial long-term investments that only experienced operators can manage successfully. Red grouper and coral trout mature faster and are better suited for intensive farming systems, reaching market size of 2 to 4 pounds in 18 to 24 months. These species form the backbone of most commercial operations due to their faster turnover and consistent market demand. Tiger grouper and green grouper occupy middle market segments, offering good growth rates and attractive appearance that appeals to restaurant buyers seeking impressive presentation fish for special occasions. The choice of species often determines the entire production strategy and marketing approach for farming operations. Successful grouper farming requires sophisticated hatchery operations that can reliably produce millions of juvenile fish annually. Modern grouper hatcheries represent some of the most advanced aquaculture technology in the world, with computer-controlled environmental systems that maintain optimal conditions for breeding and larval rearing. Broodstock management involves maintaining breeding populations of mature grouper in specialized facilities designed to simulate natural spawning conditions. These fish require precise manipulation of water temperature, lighting cycles, and nutritional programs to achieve consistent reproductive performance throughout the year. The spawning process itself requires expert coordination since grouper are naturally solitary fish that must be carefully conditioned to breed in captivity. Hormone treatments are often used to synchronize spawning between males and females, allowing hatchery operators to collect eggs and sperm for artificial fertilization procedures. Fertilized grouper eggs are tiny and develop rapidly, hatching into microscopic larvae within 24 hours under optimal conditions. These newly hatched larvae survive on their yolk sacs for the first few days before beginning to feed on even smaller organisms that must be carefully cultivated in the hatchery environment. The larval rearing phase represents the most challenging aspect of grouper farming, requiring production of specific zooplankton species that match the feeding requirements of different larval stages. Rotifer and Artemia cultivation systems operate continuously to provide fresh live food that meets the precise nutritional needs of developing grouper. Water quality management during larval rearing demands constant monitoring of temperature, salinity, dissolved oxygen, ammonia, and other parameters that can affect survival rates. Professional hatcheries employ teams of specialists who monitor conditions 24 hours a day during critical developmental periods. The metamorphosis from larvae to juvenile fish occurs over several weeks as the tiny grouper develop their distinctive body shape, coloration, and predatory behavior patterns. Survival rates during this transition period often determine the economic success of entire hatchery operations. Nursery operations bridge the gap between microscopic hatchery larvae and the larger juveniles suitable for grow-out in sea cages or land-based systems. These intermediate facilities use progressively larger tanks and increasingly complex diets to prepare young grouper for the challenges of commercial production environments. The grow-out phase represents the longest and most capital-intensive stage of grouper farming, requiring massive infrastructure investments and years of careful management before fish reach market size. Modern grouper farms utilize various systems including sea cages, recirculating aquaculture systems, and pond culture depending on local conditions and target markets. Sea cage farming represents the most common method for commercial grouper production, utilizing floating net pens anchored in protected coastal waters. These cages can house thousands of fish while allowing natural water circulation that maintains optimal growing conditions. A single large operation might deploy hundreds of cages across multiple sites. Cage construction utilizes high-strength materials designed to withstand tropical storms, strong currents, and attacks from marine predators. Modern cages feature automated feeding systems, monitoring equipment, and protective netting that prevents escapes while allowing water flow essential for fish health. Site selection for sea cage operations requires careful evaluation of water depth, current patterns, temperature profiles, and proximity to support facilities. The ideal locations provide consistent water quality while remaining accessible for daily management activities and periodic harvesting operations. Land-based systems offer greater environmental control but require significant energy inputs for water circulation, temperature regulation, and waste treatment. These facilities can achieve higher stocking densities and faster growth rates, but involve substantially higher operating costs compared to sea cage systems. Feeding management represents one of the most critical aspects of grouper farming since feed costs typically represent 50 to 60% of total production expenses. These carnivorous fish require high-protein diets formulated specifically for their nutritional requirements and feeding behavior patterns. Commercial grouper feeds contain 60 to 70% protein from fish meal, squid meal, and other marine protein sources. The formulation must provide balanced amino acid profiles while remaining palatable to fish that can be selective feeders under farming conditions. Feeding protocols vary by fish size and environmental conditions but typically involve multiple daily feedings using automated systems that distribute precise amounts of feed. Overfeeding wastes expensive feed and degrades water quality, while underfeeding reduces growth rates and extends production cycles. Modern farms employ underwater cameras and feeding response monitoring to optimize feeding schedules and minimize waste. These systems allow managers to observe fish behavior and adjust feeding rates based on appetite and environmental conditions. Water quality management in grouper farming requires sophisticated monitoring and treatment systems that maintain optimal conditions for fish, health, and growth. These predatory fish are sensitive to ammonia, nitrites, and dissolved oxygen levels that can fluctuate rapidly in intensive farming systems. Dissolved oxygen monitoring systems provide continuous measurement and automated aeration when levels drop below optimal ranges. Grouper require high oxygen concentrations, particularly during feeding periods and warm weather conditions when oxygen solubility decreases. Temperature control systems maintain water within the preferred range for optimal growth and feeding activity. Most commercial species prefer temperatures between 26 and 30 degrees Celsius, requiring heating or cooling systems in some locations to maintain year-round production. Disease management represents one of the biggest challenges in grouper farming since these high-value fish are susceptible to viral, bacterial, and parasitic infections that can cause massive losses. Professional operations maintain strict biosecurity protocols and work with specialized aquaculture veterinarians. Preventive medicine approaches focus on maintaining optimal environmental conditions, providing balanced nutrition, and minimizing stress factors that compromise fish immune systems. Regular health monitoring allows early detection and treatment of disease outbreaks before they spread throughout farming operations. The growing period for commercial grouper varies by species and target market size but typically ranges from 18 months to 3 years. During this time, fish are monitored for growth performance, health status, and market readiness through regular sampling and evaluation procedures. Growth optimization involves balancing feeding rates, stocking densities, and environmental conditions to achieve maximum production efficiency while maintaining fish quality. Experienced farmers develop detailed protocols that optimize these variables for specific species and market requirements. Harvesting mature grouper requires careful planning and specialized equipment to handle these valuable fish without causing stress or damage that could affect meat quality. Unlike smaller fish species that can be harvested mechanically, grouper typically require individual handling and assessment. The harvesting process begins with selecting fish that have reached target market size and optimal condition for processing. Professional fish graders evaluate each specimen for size, appearance, and overall quality before making harvest decisions that can significantly impact final product value. Live transport systems maintain fish in optimal condition during movement from farm to processing facilities. Grouper are extremely sensitive to handling stress and water quality changes, making professional transport equipment essential for preserving product quality and minimizing mortality during transit. Harvesting operations coordinate closely with processing plants and market demand to ensure optimal timing between harvest and delivery. Fresh grouper commands premium prices but has limited shelf life. making logistics coordination critical for maximizing economic returns from farming investments. Quality assessment during harvesting focuses on fish size, body condition, skin appearance, and swimming behavior that indicate health and market suitability. Premium specimens feature bright coloration, firm flesh, and active swimming behavior that appeal to discriminating restaurant buyers. The volume handled during peak harvest periods can be substantial for large operations. Major grouper farms may harvest several tons of fish weekly during optimal market conditions, requiring sophisticated logistics to coordinate harvesting crews, transportation, and processing capacity. Processing operations must also coordinate with luxury restaurant chains and live fish markets that prefer specific delivery schedules and handling protocols. Many high-end establishments require live delivery to ensure maximum freshness for their demanding clientele. The transformation of live grouper into premium cuisine products occurs in specialized processing facilities that maintain the highest standards of food safety while preserving the characteristics that make these fish so valuable in Asian markets. Most grouper processing emphasizes live handling and minimal processing to maintain maximum product value. Live fish processing represents the most valuable market segment, with specialized facilities designed to maintain grouper in optimal condition for delivery to restaurants and markets. These operations require sophisticated life support systems that can handle large volumes of fish while maintaining water quality and minimizing stress. Receiving operations evaluate each fish for size, condition, and species identification before assigning to appropriate holding systems. Trained specialists assess fish health and market suitability using standardized criteria that ensure consistent product quality for demanding restaurant customers. Holding systems utilize temperature-controlled water with continuous filtration and oxygenation to maintain optimal conditions for live fish storage. These systems must accommodate different species requirements while providing capacity for varying inventory levels based on market demand fluctuations. For processed products, the preparation begins with rapid chilling or stunning procedures that minimize stress while preserving flesh quality. Industrial machines designed specifically for large fish processing help standardize handling while maintaining the careful treatment required for premium products. Cleaning and preparation procedures remove scales, internal organs, and other non-edible portions while preserving maximum meat yield and presentation quality. Skilled technicians perform these operations since automated equipment can damage the delicate flesh texture that commands premium prices. Quality control procedures include multiple inspection points where specialists evaluate flesh color, texture, freshness indicators, and overall appearance. Laboratory testing verifies microbiological safety and ensures compliance with strict food safety standards required for high-end restaurant markets. Advanced processing facilities incorporate automated grading systems that use optical scanning and weight measurement to classify fish into premium categories. This technology ensures consistent grading while maximizing the value of each processed fish. Temperature control throughout processing maintains optimal flesh quality while meeting food safety requirements. Processing areas utilize specialized refrigeration systems that maintain precise temperatures while providing flexibility for different operations. Processing plants generate valuable byproducts including fish heads, bones, and swim bladders that command significant prices in specialty markets. Fish maw, processed from grouper swim bladders, can be worth more than the meat itself in traditional Chinese medicine applications. The packaging stage transforms processed grouper into market-ready products that preserve quality during distribution while meeting specific customer requirements. Grouper packaging varies significantly between live fish markets and processed product applications. Live fish packaging utilizes specialized transport containers with life support systems that maintain optimal water quality during distribution. These systems include oxygenation, temperature control, and water treatment capabilities that ensure fish arrive in peak condition for immediate sale. For processed products, packaging systems employ materials and techniques specifically designed for premium fish products. Vacuum packaging systems remove air to prevent oxidation while specialized films maintain moisture levels and extend refrigerated shelf life. Individual portioning systems create restaurant-ready products that meet specific weight and presentation requirements. Automated portioning equipment ensures consistent sizing while gentle handling preserves delicate flesh characteristics that justify premium pricing. Labeling systems provide comprehensive product information including species identification, harvest location, processing date, handling instructions, and storage requirements. Premium products often include detailed provenance information that allows restaurants to communicate quality and sustainability to their customers. Cold storage facilities maintain precise temperature control throughout the packaging and distribution process. Live fish require specialized holding systems, while processed products need consistent refrigeration at temperatures just above freezing to maintain optimal quality during distribution. Advanced packaging operations include modified atmosphere systems for processed products that extend shelf life while preserving natural colors and textures. These systems replace air with gas mixtures that prevent spoilage while maintaining the fresh appearance that commands premium prices. Distribution logistics for grouper products involve sophisticated supply chain management that coordinates live fish transport, cold storage, and delivery scheduling to meet the demanding requirements of high-end restaurant customers. The complexity rivals that of any luxury food product distribution system. Live fish distribution networks utilize specialized transport vehicles equipped with life support systems that can maintain optimal conditions during extended transport periods. These systems include backup power, water treatment, and monitoring equipment that ensures fish survival during distribution. The regional distribution network serves major metropolitan areas throughout Asia, where demand for premium grouper remains strongest. Hong Kong, Singapore, Shanghai, and Tokyo represent primary markets where consumers pay premium prices for the highest quality fish available. International shipping operations serve growing export markets in North America, Europe, and Australia, where Asian cuisine popularity continues expanding. These shipments require complex logistics, coordination, and documentation to meet international food safety and customs requirements. Cold chain management systems provide continuous temperature monitoring and control from processing plant to final delivery. Advanced tracking systems allow real-time monitoring of product condition throughout the distribution network while ensuring optimal handling at each stage. Restaurant delivery services cater to the specific scheduling requirements of high-end establishments that demand precise timing for their fresh fish deliveries. Many operations provide same-day delivery services that ensure maximum freshness for discriminating restaurant customers. Storage and inventory management systems track product age and optimize rotation of perishable inventory. Sophisticated software systems coordinate with restaurant ordering patterns to minimize waste while ensuring consistent availability of premium products. The grouper farming industry generates several valuable byproducts that contribute significantly to overall operation profitability while supporting traditional industries that depend on fish-derived materials. These secondary products often represent 20 to 30% of total revenue for integrated operations. Fish swim bladders processed into fish maw represent the most valuable byproduct, with premium specimens commanding prices that exceed the value of the meat itself. Traditional processing methods involve careful cleaning, drying, and grading procedures that preserve the characteristics valued in Chinese cuisine and traditional medicine. Fish scales are collected and processed into cosmetic ingredients, particularly collagen and gelatin products used in high-end beauty treatments. The scales from certain grouper species contain unique compounds that make them particularly valuable for specialized cosmetic applications. Fish bones and heads are processed into fish sauce, soup stocks, and protein meal products that serve both human consumption and animal feed markets. These products utilize processing equipment similar to that used in other seafood processing industries. From a culinary perspective, grouper preparation varies significantly across different Asian cuisines, but consistently emphasizes techniques that showcase the fish's delicate texture and mild flavor. Cantonese preparations typically feature whole fish steamed with ginger and soy sauce, while Southeast Asian cuisines often incorporate spicy curries and grilled preparations. Traditional preparation methods require considerable culinary skill since grouper flesh can become tough if overcooked, while undercooking fails to develop the optimal texture and flavor that justify premium prices. Professional chefs undergo extensive training to master grouper preparation techniques. Modern culinary applications include fusion preparations that combine traditional Asian flavors with contemporary cooking techniques. Celebrity chefs throughout Asia have developed signature grouper dishes that command exceptional prices in luxury restaurant markets. Nutritional analysis reveals that grouper provides exceptional protein quality with complete amino acid profiles while remaining relatively low in fat compared to other premium fish species. The flesh contains significant amounts of omega-3 fatty acids, selenium, and other nutrients that support cardiovascular health. The environmental impact of modern grouper farming represents a significant improvement over the unsustainable wild fishing practices that depleted natural populations. Responsible farming operations help reduce pressure on wild stocks while producing consistent supplies that meet growing market demand. Sustainability efforts in grouper farming include genetic improvement programs that enhance disease resistance and growth efficiency, reducing the environmental footprint per unit of protein produced. These programs work to develop fish lines that require less feed and energy inputs while maintaining premium quality characteristics. Integrated aquaculture systems combine grouper farming with seaweed cultivation and other complementary species to create balanced ecosystems that maximize resource efficiency. These innovative approaches represent the future direction of sustainable marine farming throughout Asia. Waste management systems in modern grouper farms capture and treat effluents to minimize environmental impact, while recovering valuable nutrients for other agricultural applications. Advanced treatment systems convert fish waste into fertilizer products that support sustainable agriculture on land. From the high-tech hatcheries where millions of microscopic grouper larvae begin their journey through complex development stages, to the sophisticated processing plants where mature fish are prepared for Asia's most exclusive restaurants, we've witnessed one of aquaculture's most challenging and profitable enterprises. This industry demonstrates how traditional Asian knowledge can be enhanced with modern agriculture technology to create sustainable farming systems that meet growing demand for premium seafood. The journey from larval fish smaller than a grain of rice to restaurant-ready grouper weighing several pounds showcases the remarkable biological processes that aquaculture farmers must master to succeed in this demanding industry. The precision required at every stage from spawning to final packaging represents some of the most sophisticated agricultural technology found anywhere in modern farming. The industrial scale of grouper farming operations throughout Asia demonstrates how specialty aquaculture can support entire regional economies while preserving cultural food traditions that span generations. From floating sea cages housing millions of fish to processing plants handling tons of premium seafood daily, this industry exemplifies the successful modernization of traditional food production systems. What makes grouper farming particularly impressive is its role in both meeting luxury market demand and supporting conservation of wild fish populations. Every farmed grouper reduces pressure on coral reef ecosystems while contributing to research that improves understanding of these remarkable predatory fish. The sophistication required throughout the grouper farming process, from genetic selection of broodstock to final delivery to exclusive restaurants, demonstrates the complexity of modern premium aquaculture. This industry proves that agricultural entrepreneurs can create highly profitable enterprises by focusing on luxury market segments that justify the substantial investments required for success. Thank you for joining us on this fascinating exploration of grouper farming and premium Asian cuisine production. If you found this deep dive into exotic aquaculture as compelling as we did, please give this video a thumbs up and subscribe to AgriCraft for more comprehensive looks at the world's most specialized and profitable agricultural enterprises. Leave a comment below if you'd like to see more luxury seafood documentary content, or if you have questions about advanced aquaculture practices we covered today. Until next time, keep exploring the incredible innovation and complexity of modern agriculture and aquaculture systems.